So one algorithm that I think is really interesting is something called the cache sparse method. So if we imagine that we're given some linear system, so here's our XY plane. If we're in 2 dimensions, if we think about a particular row of a linear system, that corresponds to, in 2 dimensions, some line. In higher dimensions, it'll correspond to some hyperplane. And if we draw out each of these rows in terms of what their lines look like, we might get something that looks like this. And so the solution to the linear system is the intersection of all of these lines. So that'll be somewhere like here. Call that guy X star. And we know how to solve linear systems. Obviously, we do things like Gaussian elimination. We learn a whole host of direct methods in our kind of lower level classes. But sometimes we can't do that. If we're using matrices that are really, really, really big, hundreds of millions of rows or things like that, direct methods are often too slow to actually give us a solution in a short enough amount of time. And in those situations, we have to turn to what we call iterative methods, where we make some guess and we make it better and better and better. And eventually we can converge to something that's really close to the true solution in a much shorter amount of time than we would have if we had tried to do a direct method from the beginning. So I'd like to give you an example of this. So I'll have you imagine now that we're using a matrix that is so large that we can only load one row in at any particular time. So I can only see one of these rows at once. I'll call these rows 1, 2, and 3, just so we have some sort of example. So step 1 will be just to pick some random point. I will pick this one. We'll call it x0, x0, 0, because it's our starting point. And now what we're going to do is at every step, first, we're going to pick one of the lines. So let's start by picking line 3, for example. And what we're going to do is we're going to take a step onto this line at a right angle. So something like this. So that was our x0, here's our x1. And again, we only used line 3 to make this update. So we've only loaded one row into memory at once. So I can repeat this process. So now instead, if I pick line 2, I'm going to take my step at a right angle. This is my x sub 2, x sub 3. Maybe I go to line 1 now, x3, and I can keep doing this process. And you can see that we are in fact converging to the true solution of this system. And so this is a method known as the cache sparse method. It was discovered sometime in the 1930s. And it's a very memory efficient solver for solving linear systems. And so one of the things that I study is variations of this method for other situations. So maybe either we don't have a true solution to the system, maybe we only have some approximate solution, or there's some noise in our system that means that some of our rows are not as reliable. And so there's kind of a whole class of methods based around better understanding variance of this kind of a process.